In this section, we're going to speak about public infrastructure. We're going to take a look at what PKI means and why do we need it at a basic fundamental level. So if we take a quick look at how PKI works, which has a couple of, let's say, use cases, as we saw before with asymmetric algorithms. But for example, so in PKI, we have those two entities, which we call it Roy and Rick. Not with PKI. Let's see what is the problem with regular private public key asymmetric algorithms. What is the issue? So we have on the left side Roy, which has a private public key pair, and on the right side we have Rick, which has its own private public key pair. And as you can see, each pair of Roys and Ricks perfectly make a puzzle. So the magic of the private public key pairs is that a unique private key matches a unique public key, and a unique public key matches a unique private key. So there is no way that one private key could match, could pair up with two public keys, or that two private keys can pair up with two public keys or whatever. So it's always a unique one-to-one pair of a private key to a public key, and unique association. So then what happens is that in order to use the private public key pair to provide confidentiality, authentication, and integrity, or whatever we want to provide, what's going to happen is, as the name states of the keys, each of them Rick and Roy. So Rick is gonna send its public key to Roy, as you can see, and Roy is going to send its public key to Rick. So they exchange their public keys because, as the name implies, the public key is meant to be publicly shared. The private key is meant to be never shared, to be owned only by the owner of the private key. So they exchange their public keys back and forth, and in the end, what's going to happen? If we look at one use case of private public key in there, so let's look at the data flow from left to right. Again, on the left side, we have Roy on the left side. So we have Roy on the left side. And on the right side, we'd have Rick. So now what's going to happen is that, for example, if Roy would want to send a encrypted or secure message over a unsecure medium like the internet or to Rick, what Roy is going to do is going to take its plain text message as input. It's going to use Rick's public key, which Rick has given away to Roy. He's going to take Rick's public key as the input plus the plain text message. Is going to put those two inputs in the encryption algorithm, and it's going to end up with the encrypted message. So the outcome is going to be the encrypted message, which is something which is clearly non-readable. And then it's going to send that message over the internet, or whatever the transfer medium is, to Rick. And when Rick gets the encrypted message, he's going to decrypt the message by using, of course, the encryption algorithm and its own private key. And the result is going to be, back again, the plain text message. So it's very simple. In asymmetric encryption, you always encrypt with the other side's public key. Because, for example, like if you and me want to speak over securely, want to send messages back and forth securely, encrypted, and I want to send a message over to you, what I'm going to do is that you're going to first send me your public key, and then the message I'm going to send to you, I'm going to encrypt it with your public key and send the encrypted message over to you, and you're going to decrypt the message with your private key. And it's based on the fact that I'm going to use your public key to encrypt a message out to you, it means that only the owner of the private key, which corresponds to the public key that I use to encrypt the message, can decrypt the message. So that's why it's basically secure, because if I encrypt a message with your public key, only you can decrypt it, because only the corresponding private key pair of that public key can decrypt the message. So clearly it is secure, and of course the same thing happens the other way around. Like when Rick this time wants to send a secure encrypted message over to Roy, what Rick is going to do is now is going to take the plain text message as the input, the plain message as the input, plus Roy's public key. Combine those two in the encryption algorithm and end up with the secure encrypted message, which then that message is being sent over that transport medium. It reaches over to Roy, and Roy takes that encrypted message, and he's going to decrypt that message by using the same encryption algorithm back and forth, but it's going to decrypt it using its own private key. And of course the result is going to be back again the plain text message. But the problem with this asymmetric algorithms, the main problem is that it all relies on the not on the security, on the trust level of the private public key of the public keys exchange. Because in here, when Rick takes its public key and sends it over to Roy, and when Roy takes its public key and sends it over to Rick, this process is not authenticated. There is no trust level anywhere between Rick and Roy. It's like I'm gonna go, out on the internet, and I'm gonna claim myself to be whatever, Bill Gates, for example, right? But I don't have any documents to prove that actually I am Bill Gates, right? Because of course I'm not Bill Gates. So the same problem is in here, that the main problem with basic asymmetric algorithms is that the public key exchange is not authenticated, is not trusted. So there's no trust level. Roy and Rick cannot confirm that when each of them got the other side's public key, it's actually being owned by the other side. Because what can happen in this example is that an attacker here in the middle, somebody here in the middle, an attacker. Let's say that Rick is an attacker now. Let's claim that there's an attacker in here. So what the attacker can do, the attacker can send its public key. The attacker can send its public key over to Roy, saying, "Hey, I'm Rick." So the attacker claims the identity of Rick, saying, "Hey, I'm Rick." So because Roy has no way and no meaning with default asymmetric algorithms to check if that public key actually belongs to Rick or not, then Roy is going to accept it. And of course, what ends up happening in the end, in the previous set of example, is that in this use case, then when Roy is now gonna encrypt messages with Rick's public key, and Roy believes that this encrypted message can only be decrypted by Roy's private key, which is correct indeed, but the problem is that the public key that he received is not actually Rick's public key, is the attacker's public key. So what that means is that once I'm going to encrypt a message with the attacker's public key, which I believe belongs to Roy but it doesn't, to Rick but it doesn't, then what's going to happen is that as I encrypt the message and send it out on the internet, then the attacker's private key, which means the attacker is going to be able to decrypt the message, and not only the message doesn't reach my destination, but there is no security in place because actually I encrypted the message with the wrong public key. Because again, when they exchange their public keys, there's no trust level, no authentication being done between the parties. So this is what the public key infrastructure is aimed to fix. We need a way with PKI is meant to bring up a methodology that when we exchange public keys back and forth, we're gonna make sure that the public key that I'm gonna send to you and you're gonna send to me, we're gonna make sure that it actually belongs to me and to you. It doesn't belong to an attacker. So it brings trust to the public key exchange, basically. So PKI, for that reason, is a framework. So it's not a like one thing. It's a framework, which is going to be a domain of members with bidirectional trust. And it's created, as I stated before, to support, secure, and scale public key technologies, which means the exchange of the public keys back and forth. And we have some terms or also like domain members. So we have something which is called the CA, or the certificate authority, we're going to see in a couple of what that is. We're going to have the applicant, which is going to be the certificate requester, and we have the digital certificate or the identity certificate, or how it's called, the public key certificate. So how this works is that the CA is going to be that trusted third party that verifies, issues, and revokes digital certificates. And what the digital certificate is, it's also known as a public key certificate or identity certificate. And it's an electronic document used to prove ownership of a public key. So you're going to see in a couple that exactly this is what fixes. So I need a way that when I send my public key to you, you need a way to make sure to authenticate, to make sure that that public key which you receive from me actually belongs to me and not to an attacker. So that's why a certificate is also known as a public key certificate or identity certificate, because it's meant to prove the identity or the ownership of a public key. So when we exchange the certificates, which are going to be the public keys, we have a way to verify that that public key actually belongs to the sender. And of course, it includes information about the public key's owner's identity, not only the public key, because that's the whole scope of PKI. Because when I send my public key to you, I'm not going to send only my public key, but I'm also going to send some identity in there to you, so that you can verify that the public key belongs to who should belong, which is myself. So, and it's also the digital certificate is going to be signed by the CA's private key. So this is the scope of the CA. Now, before we move on to better, let's say, to other terminologies, what's going to happen is, let me show you in here from Wikipedia the exchange process. It's going to make a lot of sense, and then we go over the theory. Let's zoom in a bit more. So this process is going to be divided into 3 main steps, pretty much. So we have in here the certificate authority, the CA, and the developer is going to be the certificate requester or the supplicant, certificate requester or the supplicant. So this is let's say this is the router or the device which needs a identity certificate. Again, as you're going to see in a couple, the identity certificate or the digital certificate is nothing else but a public key with some identity data attached to it to prove the public key's ownership. And this public key has to be issued or signed by a certificate authority. That's the scope of the certificate authority. So as the name implies, the certificate authority is meant to validate and generate public key certificates. So the step number 1 in PKI is that the certificate authority has to be enabled. That's step number 1 in here. So we have to configure the certificate authority. So how this works is that first of all, the CA is going to generate also by itself a private public key pair. That's step number one. So this is in this step the CA has to be enabled, has to get active. So what happens? The CA generates a private public key pair, and the public key is going to be the public key. It is going to be this key, and the private key. Let's put the public key with green, which can be leaked, and a private key with red. So that's going to be the public key, and this is going to be the private key. So the CA generates a private public key pair. And what the CA does, because it's the first, let's say, member of the PKI domain, what the CA is going to do is that it is going to generate its own certificate. So the CA also needs a certificate. We're going to see for what scope. And because there is nobody else in the PKI domain first other than the CA, then the CA generates its own certificate. And what that means is that in that certificate is what the certificate contains. It contains the public key of the CA and identity information of the CA. Like what is the name of the CA? What is we're going to see in a couple it contains a lot of our data. We're going to see in a couple it's going to make much more sense. But it contains the identity information of the CA, like the name of the CA, and also it contains the public key of the CA. So that couple, that pair of the CA's identity information and the CA's public key, that pair of information is going to get signed with the CA's private key. And that's a certificate. So the CA has a self-signed certificate, which is nothing else but its public key with its identity information signed with the CA's private key. Now, next step that's going to happen is that the requester now needs to get a certificate. And the easy way for me to always explain PKI is by making a comparison with, for example, with a government which issues passports. So let's take this example of PKI enrollment, getting a certificate, and compare that with getting a passport in your country. So far what happened, the CA got enabled. It has, it has a self-signed certificate, which to compare that with a passport issuing process, it means that at this point the government has, enabled a entity which can issue passports to their citizens so far. And of course, that CA, what that entity has, it has of course a name, an identity. I mean, you know where to find that CA. You know where to find the entity, the government, the location, and how is it called, and who works there. You know the identity of who issues certificate, the passports in your country. The next step what's going to happen is that. So that was the step number one. The CA has to get active, which means CA has to generate a self-signed certificate. Step number two is that now the applicant, the supplicant, the device which wants a digital certificate has to perform what I call the CA authentication, which means has to trust the CA. So what happens is that the applicant is on this right side in here, and the CA is on this left side in here. Oh, this is the CA, and this is the applicant who wants a certificate. So initially what the applicant does is going to go to the CA and tell, hey, give me your public key, your certificate. Give me your certificate. Give me your certificate. because initially the applicant has to trust the CA. And what happens? The CA is going to send back over to the applicant its self-signed certificate, which again is nothing else but the CA's public key with the CA's identity, and that information is going to be signed by the CA's private key. Now, when the applicant receives the CA certificate, so remember that the CA certificate contains the CA's public key. That's the CA's public key. So PK contains the CA's identity. So that's the CA's identity. And this document, this electronic document, which is the certificate, this document is being signed by the CA's private key. So what this means is that when the applicant receives the CA certificate, the first thing it's going to do is that it's going to take the public key attached to the certificate and use that to validate the signature. We're going to speak a bit more how the signature is being done. But as it's going to see, the signature is nothing else but a encrypted hash of that document, of that certificate. So what the applicant does is that it's going to take the public key attached to the certificate and use that public key to decrypt the signature of the certificate. And if that process works, that confirms that those private and public keys were a perfect pair. Because the applicant needs to make sure that he got the certificate from the actual CA itself, not from a spoofed CA in there. So the fact that the applicant receives as the CA certificate the CA's identity, CA's public key, and that makes up a document which is signed with the CA's private key. Then what's going to happen is that when the applicant receives that certificate again, is going to take from the certificate the public key, because the public key is contained in a certificate, because that's the scope of a certificate, to prove ownership of a public key. It's going to take that public key and use it to decrypt the signature in there. And if the decryption works, is successful, that's going to prove ownership of that private public key pair. And of course, the whole security stands in the fact that a private key is not exportable. So the fact that I can use a public key to decrypt a signature which was encrypted with a private key, it means that that public key owns to the owner of that private key, which confirms the certificate's identity. So step number 2 was that the applicant has requested a CA certificate to trust the CA. If we compare this with the process where you're going to go to your government to issue a passport, this is the step that you look out on the internet to see, okay, who issues certificates, who issues passports in my country, and how can I reach those entities, and how are those entities trusted? So you're going to make sure that you go in the proper place to go and submit your request to get a passport. Now when the applicant has to now the applicant has received the CA's certificate, it trusts the CA, now it needs who to speak with, and now the applicant wants to get a certificate. So what happens, the first step is likewise the applicant is going to generate a private public key pair. And likewise the public key is going to be this lock, this is going to be the public key, and the private key is going to be this key in here. That's going to be the private key. So the applicant first generates a public-private key pair. Then what the applicant does is that it's going to generate a certificate sign of request, or CSR. And what that means is that the CSR is likewise nothing else but some data or a document. That's the CSR, which contains the applicant's public key. So contains the applicant's public key, which is this green, that's the applicant's public key. It contains the applicant's identity. And this document, this certificate signing request, is being signed with the applicant's private key. So to compare this with the passport, with the passport issuing process, is like now you go to your government, to that entity which issues passports, and what you do is you fill in some data which is your identity, your name, your birth date, your whatever, your identity, your height, your weight, the color of eyes, and so on. They also make a photograph of you. So you fill in some data in there which is your identity. Then the public key that you attach in there, it's the picture that they take from you. And that picture, your public key, alongside with the data you have filled in there, your identity, then you sign that document, right? You sign a request saying, okay, this is who I am, this is my public key, my picture, I want a passport. So that's the process. You send a certificate signing request, or in the other case, you send a passport request. And what a passport request is, or the certificate signing request, is your identity and your public key as a document which is signed with your private key, which is your signature. And you send that information over to your government saying basically, I want a passport, or I want a certificate signing request. Now the first thing that the CA does is it has to validate. It has to do two steps. Step number one, it has to make sure that this request was not spoofed. It came in from a let's say from the real owner of that public key. The first thing the CA does is she's going to check the integrity of the CSR. Which what this means is that it is going to take the public key attached to the request. It's going to take the public key attached to the request, and likewise use that to decrypt the signature. And if the process is successful, that's going to prove that this request came in from the owner of the private key, who also owns the public key attached in the request. Because remember, it's always that one public key corresponds to one private key solely. There's no way that you can have one public key to correspond to two private keys, or one private key to correspond to two public keys. So when the CA receives that request and is going to take the public key attached to the request, is going to use that to decrypt or to validate the signature of the request. If the process is successful, it means that this is a proof that this request, this public key, came in from the owner of the corresponding private key. After this process is being done, the next step is that the CA has to validate the identity in the request. So if you compare the first step with a passport request, it means that in here they're going to validate your signature to make sure that when you sign the document, that signature belongs to you. Then the second step that the CA does is that once the signature was validated, to make sure that the request came in from the owner of that public key, then the second step that the CA is going to do is going to look at the identity information from the CSR and confirm that is correct. Like when you fill in the data that say you when you want to request a passport and you put in there your name, your first name, your last name, your birth date, your parents' name, and so on. You put a lot of data in there. Likewise, they're going to verify to make sure that that information is valid, correct? So likewise in here, when the applicant wants tells the CA, hey, I want a certificate. This is my identity and my public key. First, the CA has to validate that identity to make sure that it's not a spoofed identity. And if this two steps are valid, now the CA issues or grants the public key certificate, which in the scope of the passport, it means that if those two processes were successful, it means that the government is going to issue your passport and send it over to you. So what the certificate is mainly is nothing else but the CSR received from the applicant. So this is going to be the CSR, from applicant, which means is this it is the applicant's public key and the applicant's identity information. And what the CA does is that it is going to sign that CSR with the CA's public key, private key. So the CA uses, this is the CA's private key, which is being used to sign that CSR document received from the applicant. And then the CA issues the certificate and sends over the certificate to the applicant. So like to simulate this, to compare this with the passport issuing process, it means that when they give you your passport, in your passport you find nothing else but your identity, your first name, last name, birth date, parents' name, where you live, location, and so on. So your identity, which you had filled in your passport request. Also your picture, which was your public key. So your passport is going to be nothing else but your public key, which is your picture, with your identity, which is what you filled in the request. So it's going to be the certificate signing request, your identity, and the public key, and that's going to be signed by the government's private signature, because they put in there something which only they can verify, a specific signature. Like is the same thing with money. They have a specific fingerprint in there, not to be easily fakeable. So the same thing happens with government. So basically the certificate is nothing else but the applicant's public key and the applicant's identity signed with the CA's private key. That's why the digital certificate is also known as a public key certificate, not only as an identity certificate. So now let's see how this helps in that process of the public key exchange process.